For this example, we're going to write each logarithmic equation in exponential form. This is a logarithmic equation. It has a logarithm in it. If you read this from left to right, we would say log, and then this little number down below is a subscript, and that is the base of the log. So we would read this as log base 9 of 9 is equal to 1. When you write this in exponential form, the base of the log becomes the base of your exponent. The number on this side becomes the power of the exponent. So basically, what we have is this. You take your base and write it with this exponent, and it's equal to this value here. So this 9 raised to the number on the other side of the equal sign, that is equal to this number next to the log. So when you go from log form into exponential form, you don't have a log in there anymore. One way that you can kind of think of this that's a little easier to think of is this. You take your number 9 here, which is the base of the log, and you swing that over to the other side. And if you did that, you would have a 9, and then this would become an exponent. And on this side, all that's left is this 9. So it's the exact same thing, but rather than memorizing the pattern, this kind of gives you a visual as to what you can do to go from logarithmic to exponential form. You can swing the base of the exponent over to the other side. That will become, you can swing the base of the logarithm over to the other side. That will become the base of the exponent. The number on the right side of our equal sign here all by itself is the exponent, and then you copy down the other number. I'm going to use that visual to do a couple more of these. So for letter B, I'm going to do log base 4 is equal, log base 4 of 1/16 is equal to a -2. So again, if you just memorize the pattern, we would do 4 raised to the -2 power is equal to 1/16. That's the same thing I did here. Or if you're doing more of the visual, you do end up with your values on opposite sides of the equal sign, but we can take that 4, swing that over to the other side. That becomes 4 to the -2, and that's always going to be equal to your number that was next to the log earlier, at least on the same line. It wasn't the subscript. So you can see you get the same thing on both of those. Somehow you have to have that pattern memorized. One more, this time with something with a variable. Log base B of 1 is equal to 0. So again, we can take the base of the exponent, which in this case is B, swing that over to the other side. That's going to give me B to the 0 power, and that is going to be equal to that other number that was next to the log. So B raised to the 0 power is equal to 1. So your final answer on these, you can think of that either way, but your final answer on those, that's what we end up with for those values. That's how you can change something that's in a logarithmic form into something that is an exponential form.